Hello and welcome back to my RC channel. Today's episode is going to be about gimbals, specifically the 3-axis Good Luck by gimbal, and we've got it here. This is the box that it comes in, so let's open it and see what we get. So, we've got the gimbal here. Now, I was quick off the mark when this was released and I got the first version, so it looks a little bit different now. What they have done is they have taken the yaw motor and swapped it out with these bigger, more hefty motors. I think they've just done that though for production costs. I think the wires are a bit neater on the updated version as well. This wire just sort of hangs out here. So let's see what else you get in the box. You get this bag here, and you get a load of cable ties. Well, I did in this one anyway. And of course you get the top plate as well. So what do you get in this bag? Well, you've got a lead for the RC inputs there. You've got one of these GoPro straps here, but I'm not going to be using that. I'll explain that in a bit. You get these rubber dampeners here, which I'm pleased to see are really strong ones. You get an extra couple of screws and an Allen key and things like that. Now I'm using the Xiaomi Yi camera here, and you can see that I have banded it on. Unfortunately, the sensor underneath is screwed in and it covers up the tripod hole, but a rubber band absolutely does the job for keeping it on. There's no problems there. So I just want to talk about a couple of differences between the 3-axis gimbal and the 2-axis gimbal. This is the 2-axis gimbal in the videos before from Banggood here. You can see I've got another Xiaomi Yi bolted on the bottom of it. I love this camera. But anyways, obviously the first thing that is different is the fact that we've got a third motor. 1, 2, 3. And that is what the 3-axis is, compared to this one, which has just got the 2 motors, which means the yaw of the aircraft is going to be followed through on the image, any sort of jitters or anything on the yaw. However, this one here, actually, when you move the yaw on the craft there, it's going to dampen it also on the yaw and also the other axes. So these gimbals look pretty similar. In fact, they even got similar sort of parts, apart from the color obviously, but this is where they differ here, and it's the controller board. So this is the Alex Moss board here, and this is the Storm32 board. Very different controllers, very different software. So this one here is actually a cloned version of the Alex Moss 2-axis board. The genuine ones are really expensive, so this is 8 bits, but this one is 32 bits. Now, what does that mean in layman terms? It basically just means the higher the number, the better. The way that I can relate to it is when I was younger, I had a Sega Mega Drive that had a 16-bit processor, and then a 32-bit version came out, and that one was better and faster, and it's the same with these. Now, you can get a 32-bit version of the Alex Moss board, but they're really expensive, and this is really cheap. You can get a version of this on Banggood for £14, which is just amazing. Now, before we go any further, I have made a modification to this. This is the power cable here, and it had one of the balance cables for a LiPo attached on the end for it, which, you know, is sensible. If you're plugging your LiPo into your quadcopter, you can plug the balance port into this and it powers it. However, I am using mostly JST connectors, so I have connected a JST connector to it there, and then this just goes in here like this to power it up. Now, this is my test rig that I'm going to be using for the gimbal. You can see here, it's just a landing skid that attaches to the quadcopter there, and it's got this front plate here, which I have cable tied a different plate on there. I'm not going to use the one that it comes with, although it's very nice. I've already got this one attached to here, so let's get the gimbal on here. Now, the mistake that I made when I first got this is I powered it up, and as you will see, I twisted it around and nothing happened, and I thought, oh, there's no settings loaded into it, and I quickly plugged it into the computer and fiddled with all the settings, not realizing that this thing takes quite a while to boot up. I'm used to the Alex Moss board, and it boots up within a few seconds. However, this one is really worth waiting for. So in a minute, you can't see very well in the video, it will beep there, and that means it is initiated, and you'll see it's starting to stabilize. So I wasn't able to use the stock PID settings because I messed around with it. However, people have reported that the stock PID settings, they work, but they're not perfect. So we're going to look at that in this video. Okay, so if you want to go in and change the settings, you're going to need to go on the computer and go to a website, oliw.eu. It's in German, but if you go up here to the Storm32 link here, this is all the info on the Storm32, and if you scroll down here somewhere, there's a download section here. See, downloads, and you can download any version of the firmware. And what I did was I clicked this link here to GitHub, and if you press download zip here, you have to expand this open up here. So yeah, if you press download zip, it all downloads into a zip file, and what that gives you is every single version. So that folder is here. And if we go into here, and then firmware and binaries and GUI, you can see there in all these folders that you've got the different versions. So when I first got the gimbal, I didn't flash the firmware. The only problem is I didn't know which version I had, so all I did was I opened the latest one, which was version 8.0, and you've got these executables here, and I powered up the gimbal with the camera on it, and then I took my USB cable and plugged it in as well. The computer made a noise and it installed the correct driver, and then what I did is I opened the executable, the latest version. It does take a while to open, so don't be alarmed with that. There we go, and here it says you've got COM port 5, which is the one that it's connected to there. I don't have any others connected. And then I pressed connect, and it says here the controller, the firmware version is not supported. Retry with GUI version 7.0. So I did that. 7.0. Open it up. Okay, so if we go to COM port 5 there and press connect, there we go. Everything goes green, and that's how you know you have connected. It also says here that battery is connected and the voltage is sufficient. I'm using a 2S to power this up. Okay, so I'm going to update the firmware to the latest version. I just want to state that when I got this and tuned this, I didn't do that. It came with version 0.7 and it worked fine, so you don't really need to do this bit, but just so that it's a complete video, I'm going to show you how to do it anyway. You're going to need an FTDI adapter, and you're going to need one with male pins. Some do come with female pins. I have this one from a previous UHF project, so bear that in mind. They cost like £2 from China. Just another quick one on the FTDI adapter. They do come in 3V and 5V versions. That doesn't matter because we're not using the power through it. We're just using the ground, the TX and the RX, so don't worry about that. Now you can use the leads that came with the gimbal, but I've got these extra ones here because you only need 3, right? And these actually do connect to the RC pins here. This is your ground, and this is RC0, and this is RC1. And so the way that it connects here is the ground connects to the ground pin on the FTDI adapter. The next one is the TX, so it goes to the TX there, and the next one is the RX there. Now, you do power this from the USB as well, but it's not connecting to any info. It's literally just powering it. So you need to have 2 USB cables, or you can power it from the battery as well, but do bear in mind that we don't want any power cuts or anything like that. We could end up bricking the unit. So I'm going to plug in the FTDI adapter. So what you need to do is load the gimbal into bootloader mode, and I will just power this up here. So this one is just going to do the power. What you're supposed to do is when it's switched on like this, if you press both of the buttons together like this, and then come off the reset button, and then off the boot button, you see those lights don't come on, and I know that it's in bootloader mode. So let's go over to the computer. Okay, so we've got all the different versions here, and 0.8 is the latest one, so I have opened it already because it takes a long time to load. And here we go, we've got the flash firmware option on the last tab there, and what you want to do is select the board version. Now, this could change, but this is version 1.31. That's what's currently shipped with the gimbal. I can't say that that won't change, but so be aware of that. Just make sure you know what version of the board is. But I think it was set to 1.3 as standard, but I have changed it to 1.31. Firmware version 8.0 there, and it selects this file automatically, the hex file there. We don't want to change any of this. What you might want to change here is the COM port. Look for the one that says VCPO, and that is your FTDI connection there. You want to verify once it's been flashed, and you don't want to do a perform full chip erase. Well, I don't anyway, because I've already done some tuning with this, and I think you'll lose those figures if you select that. So it's quite good that you can flash the firmware and still keep all your other settings. So the next thing to do is press flash firmware, and a little DOS screen comes up, and this takes a while to do. You can see there that it is verifying everything that it has written to the board, which is nice. And there you go, it says press any key to continue, so I'm just going to hit spacebar, and it closes down. And if we go back to the main page now and press connect, and you can see that it is running, and it says version 0.8 at the top, and you can see there it's kept all my PID settings, all my RC settings, which is great. So flashing the firmware, updating it, doesn't get rid of your settings. That is a big plus for me, because I didn't really see the need to upgrade the firmware, but if it's not going to wipe everything, then that is fantastic. Now, these aren't the stock PIDs, these are the tuned PIDs, but try and ignore that for now. We'll get to that later. The first thing that you are going to want to do is go to the gimbal configuration window here and select the configure gimbal tool. Make sure all these are ticked and press continue. Please level the camera roughly by hand, should be within 15 degrees. That looks about right. Press continue. Okay, please tilt both the camera and gimbal down by 45 degrees without rolling. So we hold the camera and tilt it. This is to find the orientation of the sensors. It's found it. So then press continue. Number of motor poles, leave to 14. The motor direction parameters will be configured to auto. Press continue. The gimbal needs to be restarted to work. Okay, press continue. And this takes a while. It's going to restart the gimbal up. Okay, and when it beeps, that means it's done. Current motor directions will be read from the board. Press continue. The current pitch and roll motor position will be read from the board and copied. Press continue. Okay, here is now where you can trim the yaw out if it's needed. So I'm just going to have a look. It doesn't look too bad. Let's just move it a bit to that. No, it's the other way. Sorry. Yeah, that looks about right there. Okay, so press continue. And then it's telling me I should have fun. I think I will. Press OK. It's going to re-enable the motors and store it to the EEPROM, which just basically means it's going to save the settings to the board. Goodbye and have fun. I will do. Okay, so after you have done that, you will want to calibrate your accelerometers here. Now, you've got a few options here. You can run a 1-point calibration or a 6-point calibration. And it's undecided which one is better. It's certainly easier to do the 1-point calibration, so I'm going to do that today. I may do another video where we do the 6-point calibration to see if we get any better results, but honestly, I've had great results with this. So the first thing that we want to do before doing this is make sure that our gimbal is absolutely level. And the best way to do this in my opinion, is to use a spirit level. So I have mounted a box here so that the IMU is level here, and also I'm making sure that with the spirit level that it is as near as possible as flat by looking at the bubble there, and it's pretty bang on there. And also the same with this up here, making sure that the top one is level as well, which it is, so that's great. So before we get any further, let's just clarify a bit of jargon. You will hear people saying the word IMU, right? And that is short for inertial measurement unit. And it's just basically, just means a sensor, like the accelerometer in your phone, right? And this gimbal has two of them. It's got one underneath here, and it's also got one built in as well. And what we need to do is get them completely flat so that when we calibrate them, the horizon is going to remain level when we are yawing. So if we go back to the computer, you can see here we've got two IMUs listed there. So the camera IMU is this one here at the bottom, and the IMU2 is the one on the board. So let's do the second IMU first, which is this one. If we press 1-point calibration here, can see there that it starts to run numbers, and eventually see it'll say accept current reading. So I'm just going to wait a little bit for these numbers to stabilize. They seem to be doing that, not really changing now. So then we press accept current readings and then press OK. And then for the camera IMU, what I'm going to do is, some people add weight to it or a battery. I'm just going to press it down and hold it firmly with my hands to make sure that it's not moving. And then we're going to do run 1-point calibration there. We're going to wait for these figures to come down nice and low. 65, 40, that's quite nice. Accept current readings, and then OK. Once you have done that, you want to make sure that you click Store Calibration. So the next thing, PID settings. So PID settings, what are PID settings? They seem really confusing, but when you break it down, it's not that confusing at all, and it kind of makes sense. So let's start at the top with P. So P stands for proportional. And what does proportional mean? Well, it means a variable. So there's a great example, a great analogy that I like to use, and it works well with our gimbals. So most people drive cars, I'm going to assume here, or understand how you drive a car. So if a car is stationary and you want to get to 30 miles an hour, you put your foot down on the accelerator and you get to 30 miles an hour. But what happens when you reach 30 miles an hour? You don't keep your foot on the accelerator, otherwise you just keep going until you just went over the speed limit. So what you do is, when you get to 30 miles an hour, you lift off the throttle and you put back on the throttle, and you sort of lift off, put on, lift off, put on. And so the dial there stays at 30 miles an hour. And that is what the proportional gain is. Basically, it's a figure that says how often do we adjust that variable. If we are adjusting it fast, so let's say the limit is 30 miles an hour. If we've got a high adjust figure, it's going to overcorrect. It's going to go over the 30 mile an hour point, and it's going to go under the 30 mile an hour point quite fast. And if this happens with a quadcopter's P gain, then it starts to be really jerky and oscillate. Same as if the figure is too low, it's not going to correct enough, and you're going to get oscillations, albeit more docile oscillations. So that is what P gain is. Now the next one that I'm going to move to is D, and that means derivative, right? And when you look at derivative in the dictionary, it means like, say, a copy of something. You know, when you say the word, oh, this is derived from such and such, that's what derivative is, but it doesn't really matter what the word means. Let's just say, right, we're traveling at 30 miles an hour, we've got our P gain set perfect so that either side it is correcting and keeping us at 30 miles an hour. But what happens if the car hits a bank? If the car hits a bank and you are adjusting to that 30 mile an hour sort of speed, then when you hit the bank, the car's going to slow down because you're not compensating for the bank. So that's what derivative is. It compensates for changes in angles, right? So you would think that those were the only two things that you will need, right? But the I gain stands for integral, right? Or integer. And if we go back to mathematics when you're at a school, I had to look this up because I wasn't very good at maths, but integer is a whole number, right? An integral means all of the things that are required to make a whole, and that's what I gain is. So between the P and the D, it's going to create errors, and what the I gain does is try and fill in the gaps of those errors to get a complete whole stabilization system, and that is what it is in a nutshell. It doesn't really matter knowing those things. I think it is kind of handy to know it, but you don't really need to know it while tuning. So there's a complete tuning recipe for PIDs, and we're going to go through it now. So the first thing I'm going to do is set all the PIDs to 0. You probably think I'm going to be crazy, but that's what we're going to do. Set all the PIDs to 0. Let's keep going. Oh dear. All that good work just wasted away there. Everything to 0. Now, one thing that I'm not going to do is put the Vmax to 0. So let's explain Vmax first of all. So Vmax is the strength that is going to be applied to the motors from the battery. And that is important for a couple of reasons. The voltage on this board isn't regulated, on this controller board. If you plug in a 2S, you're going to get 2S power to the motors. A bit like if you were to plug a 2S into a quadcopter, it wouldn't be very powerful, but if you plugged in a 4S, it would be extremely powerful. So I'm using a 2S here, but what a lot of people are doing is attaching what's called a voltage regulator before the battery. That means that the voltage stays stable on the board. So no matter what battery you plug into it, you get a consistent voltage. Why is that important? Because if the voltage is lifting up and down, then the tuning gets affected because the motor strength here does affect the PID settings here. So what we've got is something called voltage correction here, which you will have to play around with. I haven't really done that, but if you increase this, it's going to correct for the drop in voltage. It's going to simulate a voltage regulator, but really the best thing to do is if you're having problems with this, which I'm not, then put a voltage regulator in. You could put any values in here to start off, but these are the values that I have found work the best, and that is 93 on the pitch motor, 172 on the roll, and the maximum on the yaw. So why have I done that? So the reason is your motor is taking the brunt of all the weight. It's not only got to carry itself, but also the pitch and the roll motor, okay? So I've got it set to maximum because we want to ensure that there's enough powers going to the motor that any wind resistance that we have is not going to affect or knock the gimbal. We need to make sure that the power of the motors overpowers the wind, and that is really what these settings are for. Now, I get asked a lot, oh, can you give me a copy of your PID settings? And I'm like, yeah, I can, but that's not the way to go about it at all. Same as a quadcopter. Each quadcopter, you could build identical quadcopters, and the PID settings could be different. And the fact that they keep changing this gimbal, updating it so much, to me says that you really should start off everything at 0. You shouldn't go copying other people's PIDs and try and correct them, because the best thing to do is to start right at the start and just have the PID settings that are for you. Of course, you are absolutely welcome to try out these PID settings that we're going to do in this session, but I wouldn't recommend it. I would definitely go and make your own PID settings. So now that I've got all my gains set to 0, there's a couple of other settings I need to change before I can start tuning. The first one is on the setup tab, and it's the motor usage. Now what I want to do is disable the roll and yaw motor, and that is because we want to tune one axis at a time, starting with the pitch motor. So I'm going to disable that one and disable that one. And also we want to go into the pan settings there, and it's set to hold pan here, but we just want it to hold. That's the pitch, roll, and yaw axis, so everything's gonna hold its position. So I'm gonna click here and write and store, and we're ready to start our tuning session. Now, before I start, I want to state that I'm tuning this all through the USB cable. I've got a really long USB cable. What people are doing is installing a Bluetooth module on top of the board here, and you can tune it wirelessly. Now, I don't want to do that because a Bluetooth module is going to transmit certain frequencies, and I think there's going to be a lot of frequencies going on with this setup anyways when I add FPV, UHF, APM, the whole lot. So I'm just tuning it by the cable, and I've had no problems doing that. I understand that people may want to tune while they are flying, so you are welcome to fit the Bluetooth module, but I'm not going to do that. I've had no problems tuning it like this. So we're going to start off tuning the D gain on the pitch motor, and it seems a little bit backwards to how PID is explained, but basically you want to start with the D gain and then the I and then the P, so you work backwards. Okay, so what I'm going to do is we've got the battery plugged in here, and we've got the USB plugged in, and what I'm going to do is increase the D value here until we start to get vibrations on the arm. I'm actually touching it with my hand here, and I'm looking out for vibrations, so I'm going to set it quite high, and each time we make a change I'm going to press this tick box button, and you can see it changes to write and store. It changes it in real time if you do that. So if I press write and store, now you won't hear it probably, but it is vibrating there, so the D gain is too high. And what we want to do is get these values as high as possible without vibration, because it's going to be more accurate that way. So that's vibrating there. I'm going to reduce it down a bit more and press write and store, and that vibration has stopped, but I'm feeling it with my hand and it is still vibrating slightly, so I'm going to reduce it a bit more. Still getting slight vibrations, but it's considerably less. Down to 7. Absolutely no vibrations. Excellent. So I'm going to leave that there for now. And next, move on to the I gain. So again, I'm going to lift it beyond what it's probably capable of, and we're going to look for vibrations. So we're not getting really many vibrations there. What I'm going to do is turn this up to real maximum so you can see what turn it up too high does. And you see there, if I sort of knock it, starts to get a nice little waggle on it. And even if I try and hold it in place, it doesn't do much, so I'm going to reduce it down, do write and store. Still waggling if I knock it. So that's no good. It sort of stables out, but we want to make sure that when we knock it that we don't get anything at all. So I'm going to reduce it right down there to 115. You can see there when I knock it, it stables out itself. Okay, so I'm going to leave that there. And lastly, we've got the P gain, which I'm going to increase. I'm going to go really high to show what happens if we go too high. You can see there that it sort of waggles. It's not too bad though. What happens if we... So all these other motors are disconnected, so you can see there that it starts to work. But that gain's a little bit too high. I'm going to reduce it slightly to about 6. You've definitely got a lot of leeway with this. So reduce it to 6, about nearly 7. Let's get it there. And do write and store. So now we've got the pitch working, see? But none of the other axis, okay? So now I'm going to enable the roll motor. So if we go back to the setup and go to the roll motor, and I'm going to change that to normal, right, and store. So here now, nothing happens on the roll, but if we go back to the main tab, and then I'm going to start again on the D value. So let's increase that to really high, higher than it wants to go. And we've sort of, yeah, it's sort of stable there, but let's see what happens if we go to the extreme. That's definitely vibrating there at the extreme. And you can actually, well, I don't know if it's going to come through on the camera, but that is vibrating quite considerably there. So I'm going to reduce that down. It's still vibrating slightly. I'm feeling it with my hand here. Very slight vibrations coming through still. We don't want any at all. So let's reduce this right down here to about 1,000. There. No vibrations at all. So I'm going to move on to the eye gain. Let's increase that to really high. And then we start getting a nice wobble. So clearly that's too high. I'm going to reduce it down. Still got a wobble there. Actually, if I hold it, because we've got no P gain to sort of stable it out, right? So with this one, I'm going to need to, well, I need to reduce it more. So let's reduce it down to about 140. Press right. If we hold it in position, there we go. It's stable. So let's introduce some P gain now. Let's put it right up there. Actually, I didn't do it. Let's move it right up and see what happens. See there, when it gets knocked, it's taken a while to adjust. So I'm going to reduce that right down. Reduce it down to, I don't know, about 3. Okay, so we should now have roll. It's acting quite nicely. Obviously, the yaw, if I can kind of lock it in place with my hand and see that it's acting quite nicely. And lastly, I'm going to move on to the yaw motor. So we need to go into the setup here and enable it so that it's on normal. So write and store. There we go. And the yaw has now got power to it, but no settings. So let's it's just reset itself there. So let's increase the D value and see what happens. I'm going to go to the extreme, do right, see what happens. Yeah, I can feel it vibrating there slightly, so let's reduce that down. To about, yeah, it's shaking there in my hand. You can't see it on the camera, but it's definitely vibrating. And there we go. It stopped vibrating there. So I'm going to increase the I value. Let's go again. I always go to the extreme first and then reduce down. Now we're starting to get a waggle here, and if I try and stable it with my hand, it just waggles even more. So I'm going to reduce that down here. Still got a waggle for yeah, it's still doing it, so I need to go down lower. Let's see. Yeah, about there. Let's try and increase that a bit. Yeah, That seems about right. I think if I knock it, it's going to start waggling. But then if I introduce your peak gain slightly, there we go. Starting to act nice, and there we go. That's looking quite nice, isn't it? So these are my final PID settings. You are absolutely welcome to use them. However, I just want to show you something, right? Now, I'm using a 2S to power this, okay? And a lot of people will be using a 3S to power it, or a 4S to power it from the quadcopter. Now, this is where the Vmax values come into play, and it's quite important, really, because let me show you what happens. To simulate me plugging in a 3S battery, I'm going to lift up the pitch motor Vmax, okay? So if I tilt it in this position, I'm going to lift up the power here, and look what happens. I don't know if you can hear that, but we're getting vibrations. So if you want to copy these PID settings, by all means do. But I would recommend just going through the process yourself and generating your own PID settings. Maybe even get better PID settings than I've got here. But I will say, though, these exact settings, in fact, if I set this down to 92, these exact PID settings here is what I used on my channel. I posted a video of me flying this in 60 frames per second, and these are the settings that I use. You're welcome to use them. However, I would recommend going through this tuning recipe and tuning it yourself, because I do believe each gimbal is going to be slightly different. Once you have done that, you're going to want to change your pan setting back to hold pan. Otherwise, it's going to stay in the same orientation all the time. So, you can see here that no matter which position I put the gimbal in, it handles it fine. We've got no vibrations. You can hold it in really strange places and angles, and that is when you know that the gimbal is set up perfect. So one thing that I did do with this is this quadcopter that I did this flight with is using the KK2 board, and it really struggles to hold the yaw way worse than any other quadcopter that I've used in the past. And a lot of people commented to say that you need to increase the yaw pan deadband, and I did that. I increased it to 5.5%, and it didn't really make any difference. And again, I knew it was because the yaw on the KK2 was really terrible. And I was also advised, there's no information on what this does at all, but I was advised to increase this figure here to 1%, and I did that, and it made no difference. So that's completely up to you whether you use that. I'm going to be switching this quadcopter to APM soon, and then we're going to have some really great footage, I think. So the last thing, RC inputs. Okay, so I'm going to have to go rogue with the camera to show you how I've got this connected. Okay, but this is the wire that you get given with the gimbal, and it's actually got 4 cables on it, and even though there's 3 axes, there is a reason for that. And that is because the first pin here on the RC inputs is the common ground. So I've got this connected to the ground on my receiver here, which is just underneath there, and then all the others can just connect into the RC inputs. So in order, so ground, and then you've got RC input 0, which I have got set up to pitch here. So that has gone into my channel 6 there. And the next one, which is the blue one, is actually the roll. Now I've got that set into channel 8. It's just the configuration on my transmitter, and I want to have my pitch on that one, my roll on that one, and my yaw on that one, so I've just had to switch it around. But yes, so in this order, it goes pitch motor, roll motor, and then yaw motor. So let's get back to the computer and configure those settings. So I think this gimbal is definitely designed to use the RC inputs. It's a downside to it, but I can really forgive it. The Alex Moss board has a button on the top where you press it and you can angle the camera wherever you like and let go and it just stays there. And if you don't have the RC input facility, it's really useful for that. But this one doesn't have that option. So you have to connect the RC inputs. But believe me, you really want to do that because you're going to get such great footage. So let's see what options we have here on the RC inputs tab. Okay, so the important one is to set these correctly, RC0, RC1, and RC2. So the second pin along, as we saw before, is RC0, so that's going to be connected to my pitch. And of course, if you don't want to mess around with the wires and turning things around, you can switch them, but this is how I've got them set in order 0, 1, and 2. The next important one is this pitch mode here, and they're all set to absolute now, but when I got this, they were set to relative. So what absolute means is that any sort of point you twist the dial here, it stays in position like that. You see one click and it just clicks back, but if I change it to relative and then write it, if I twist this now, it's just going to keep turning. So if I do 2 clicks, it's going to keep turning and it's not going to stop. It'll stop when it reaches its maximum pitch point, but you can see there it's continuing to pan. Now that might be good for like filmography and stuff like that, but it's really tricky to fly with because you're having to center it each time. So if you see, if I want to get it back to the center now, I have to sort of bring it there, and very quickly as it gets there, bring it to 0, which isn't ideal. And I guess it's the relative option is more for if you are perhaps using a joystick or something like that, or if you're after a different kind of setup. I'm not after that, as I'm just using these dials for now, so I'm going to change all these to absolute, right, and store, and that means that I can just adjust it like that and just do a couple of clicks and it only moves a couple of clicks like that. And if I go back to the center, it centers itself. So I've got my yaw on that one, my roll on this one, and my pitch on this one. It's quite nice, isn't it? And so what you've got next is you've got the RC minimum and maximum pitches. So for example, if I don't want to get my legs in the shot, I can put this fully down here and I can change the amount of pitch that it goes down. You see there it's set to 90 at the moment. If I select it to say, I don't know, about 40, and then write and store, the maximum then becomes less, and it's not going to get the legs in shot, but I don't mind getting the legs in shot, and I want it to show the full down, so I'm gonna put it back to 90 degrees. Also, once you have clicked on the option you want to change, you can then use the up and down arrow keys for more precise numbers. It'd be nice if you could click in here and change the number, but I don't think it allows you to do that, so I'm going to press right, and it's going to, in the full maximum, go down. You could even take it further if you want. So another thing that we can change is the acceleration of this movement here. Now, I really like it at this setting, but if you want it to go slower for whatever reason, you know, it's going to go really slow now. It's still going to stop in the position that you ask it to, but you see it's going to take a while to level again. Not really going to change that for now. You never know what project comes up though, but I'm just doing all this for fun. I'm not using this in a professional capacity. Another thing that you can do is change the trim. So let's say that your roll axis is slightly out when it's centered there. You can do auto trim as well. So if I press auto trim, it's going to save the trim settings there and try and guess it, but let's just mess around with that. So let's just change it to the extreme and see what it does. Yeah, it just adjusts the center point of the trim so you can get it nice and level. So I'm at 0 there, and it still seems slightly off. So that auto trim feature not really doing its job there. I'm just slightly adjusting it here. What happens? Does it only let us go that far? Oh no. There we go. Yeah, that's about right. I'm going to leave it there. Just one other thing that you can do, it's not on the RC Inputs tab, but if you click on Functions here, you've got Recenter Camera. This is quite a cool one, and I think I may set this up, like, once I've got the yaw dialed in. I mean, I don't really see the need to have the yaw, other than for trimming purposes, but it's not a big deal. So what I can do is, if I go to the RC inputs, and if we just disable the yaw there, I'm gonna write it and then go to functions and change that to RC2. What I should be able to do now is, if I start messing with this, but then move this one, there we go, it recenters. So it might be quite, it's better to have that on a switch really, but I've ran out of channels here. But yeah, it's quite nice. Look, it does its job, it centers itself. So this option up here, RC deadband, it's not really relative to what I am doing. In fact, I'm gonna reduce it down here, and actually you'll see if I reduce it down and press right, it actually performs a little bit better. And I think what the RC deadband is it's a deadband either side of this, and we don't really need that because these click here, I can be quite accurate with this. But I think this function is for if you're using a transmitter to control the gimbal here, and your fine movements here will need a slight deadband, but we don't really need that on this, so it seems to level itself a little bit better with that turned off, so I'm going to leave that there at 0. That is pretty much it for the RC inputs. So here is some sample footage, and if you made it this far into the video, congratulations. I know it's been a really long video, but I wanted to show all of the steps that I took to get this great footage, and I think you will agree it is really great footage. Now, I think a lot of people are going to be interested in this gimbal. It's really cheap. $70 US or 42, 43 GBP, whatever the rates are. And the results are absolutely stunning. I know some of my subscribers are probably thinking, I've seen this video before. Yeah, I recorded this with the Xiaomi Yi in 60 frames per second, and I uploaded it without any commentary or anything like that. I just wanted people to see, with the smoothness of the gimbal and the smoothness of the 60 FPS, what a great result that I got. This is rendered in 30 frames per second, and I didn't want to render the whole tutorial in 60 frames per second. The file size would have been far too big, so yeah, that's why I did that. So I do just have one concern about this gimbal though, and that is the fact that they keep changing it. Now, I was very quick, as I mentioned, when this came out. I bought it, and I got what people are calling version 1, and that is, it's got the bigger motors. I say bigger, they're actually smaller motors, but they're heavier casing, the 2208 motors, and since then, a lot of people bought it, and it turned up with more torquey motors, and the same motors all round, so the yaw, the roll and the pitch, they all had the same motors. Now, a lot of people were talking about the fact that they were really struggling to get the camera to balance on the ledge there, and I've been thinking about this for the last couple of days, and I didn't have that problem at all with this version. You can see there, if you go back to the start of the video, I banded the Xiaomi Yi onto the camera ledge, and it just balanced up perfect. It wasn't even a consideration. I mean, maybe I should have mentioned it in this video. You do have to have the camera balanced perfectly before you start the PID settings, but I didn't really have to move it about at all, so that is only my concern really. And I do have one of the later versions turning up, so eventually I can compare it. But actually I bought it because never have I seen a product before that was so good, and I instantly went out and bought another one, but that's what happened in this case. So there you go. I hope you enjoyed this video. I hope it was useful for you. Please continue to subscribe to my channel, and cheers.